Okay, so good morning, everybody. My name is Carolina Arias Muñoz. I'm a PhD student from Politecnico di Milano in Italy. And I'm here to present, sorry about the long title, but it's a web application basically to know, to find the best place to live within a city. And the team that came up with this idea, sorry, it's not working. It's blocked. Sorry. Okay. So the team that came up with this idea is the one that you see here. We are 3 environmental and geomatics engineers and 2 developers, and we belong to the Geomatics and Air Observation Lab at Politecnico di Milano. And we basically are interested in web GIS, volunteer geographic information systems, and geo-big data. So what is CityFocus? So as I said before, it's a web-based interactive 2D and 3D application, not only to find the best place in a city to live, but also to pass a certain stay in. So normally, when you want to move to another city that you don't know, you go to Google Maps or hopefully OpenStreetMap, and you check the streets and you check more or less the services that you have available because you don't know the place. And then you go to another website to check the prices of the houses, the apartments, and so on. So you have to do a lot of manual work, let's say. So we wanted to create an application in order to make all this in just one place. And also the user can decide their different criteria and their importance. And at the end, to have a map that can show them the different places within a city. So how is CityFocus different from other apps? So actually the question that we had before was, is there an app that does these things? And actually we couldn't find any app that show you places within a city. I mean, I put here just the main ones, but in this application you only, they give you a city in the world. For example, you put your income, you put your preferences in temperature or services, and they can tell you which city in the world you can go to live, but not within the city. So this is one important question. And also, we try to make it as user-friendly as possible. We hope it is, avoiding long and handmade search on the web. And also, normally when you do this type of search, you normally don't consider the environmental conditions like air pollution, temperature, and so on. So we also wanted to include this into the criteria. And most importantly, we only use open data and open specifications. So this application was a winner for the MyGeos third call for innovative apps. I don't know if you're familiar with MyGeos, but MyGeos was a project of the European Commission that finished last December. And this project, the objective of this project is to create innovative apps in the environmental and social domains. So they wanted to show the people that you can do stuff with Geos data core open data and with open data in general. So basically the idea was to develop innovative application they could be mobile or web-based, using only openly or freely available data, or also crowd-generated data in different domains, but especially addressing citizen needs. So if you go to this link over here, you will find all the apps that were winners in these calls. And you can also download this application and modify them because they are published as free content. And you can also use it for commercial uses. So as our application, you can download it in, and modify the application. Well, in terms of data, we use data specifically for the city of Milan, in this case as a demo, because we normally work with Milan and data from Milan. But actually, this can use in whatever city you want, because mainly the data that we use was from OpenStreetMap. So it will depend on the availability of OpenStreetMap data in a specific city. But we also use data from Lombardia region, the municipality of the city of Milan, the National Statistical Service, and of course the GIS data core. So the criteria that we consider just for this demo, because you can add all the criteria that you want, but we use especially environmental conditions, such as air quality and the different temperatures within the city. We also use the population density because maybe some people want to live in the suburbs instead of the center of the city, for example. And the rest of the criteria are referred to the nearness. So nearness to transportation, for example, bus stops and train and metro station, or the nearness to services such as ATMs, pharmacies, coffee shops, hospitals, and so on. The nearness to nature, so if people want to be near to a park or water stream. We also consider the land use type. So if you want to live inside an industrial or commercial type of land use and stuff like that, or nearness to education, so schools, universities, and so on. Okay, so the application principle is actually really simple in a sense that it's a map algebra, so you have different criteria that are the different, we call it score maps, that goes from 1 to 100, or to 0 to 100, or to 0 to 1. And basically, you assign weights to the different score maps, then you sum, and you obtain a final map. So it's really simple. But before we, in order to obtain these score maps, we needed to make up data cleaning and data processing before. Just once, but we needed to do it. And then these score maps went into the application. So we did, first of all, data cleaning, and then the score maps creation. We did it using Python script and GIS. So first of all, we did the data cleaning because we had data from different sources that was the same data, for example. So we tried to clean the data with buffers, because we had data from OpenStreetMap that normally was the majority of the data, but we also have the same data from the municipality that probably is not exactly in the same position. So we tried to choose one of them, and we did it by buffers. And for the score maps creation, it depends on the type of feature that we want to create. In this case, we have point layers, or polygon layers, or raster layers. So in the case of point layers, that represents services like hospitals, banks, post office, and so on, we thought of, let's say, a walking distance. So in average, we know that people don't want to walk more than 15 minutes to access a service. So approximately 15 minutes walking is 1,200 meters. So we use that distance to create a spatial concentration maps using a quartic kernel density function. And then we normalize in order to have the score maps between 0 and 1. For the case of the polygon layers, we have more or less the same criteria, in the sense that in this case, you don't have a position, but you have the whole area. So we rasterize the data, then we create multiple distance buffers, taking into account, again, this 1,200 meter distance. We divide it in different categories from 0 to 100, 1,200. And then we reclassified it, and we created the score maps. For the raster layer was a little bit different, because in this case, we already have raster data. We just needed to normalize it in order to have it from 0 to 1. In the case of air pollution, we wanted the high scores be on the less polluted areas, of course. But for the case of temperature, population, and land use layers, we tried to create 3 different layers, like categories: high, medium, low, or industrial, continuous, discontinuous. And then we create the score maps by means of reclassification. So the architecture of the application is based mainly on two components. The first one is Rasterman, raster data management, and NASA Wetboard Win. I won't enter into much detail because I know in the afternoon Professor Baumann is going to explain a lot better Rasterman. But basically it's an array DBMS that adds capabilities to storage and retrieval of array data or raster data. And NASA Wetboard Win, as you know probably, is a 3D virtual globe. It's open source and customizable. And you can add it to any web application. So as I said before, CityFocus relies on a standard installation of Rasterman. This standard installation has normally SQLite database backend. For us, it was okay because we only have like 20 maps, so it was fine. But actually, you can connect it to other type of databases like Postgre and so on. And basically, data are accessed over the web by Petascope component of Rasterman. This component is the one that translates the web coverage processing service queries from the standard of GC. And it's translated into the Rust SQL language. And this is what allows us to create the map algebra. I'm going to show you how it's done. And for the client side, combining jQuery and Wetboard Win, it is possible to retrieve maps from Rasterman to the WPCS and show them to the end user. So apart from the raster data, we also wanted to show the vector data, so the locations of the different services. Because we were working with Rasterman, we didn't want to access to this vector data through a database. So we just added to the application using a GeoJSON. So it is only in the client side of the application. And the final map, as well as the different score maps, were, let's say, painted by coloring a grid, so a vector version of the raster grid, using the values of the retrieved CSV files from the WCPS request. We know that there is a way to color data using the WCPS, but we find it really not aesthetical. So we prefer this way, which was very much better. So the WCPS requests are done in these ways, are very simple. You have to call the different layers, and then you make the map algebra, and you request your data. In this case, we use CSV, but you can request it using TIFF or JPEG. So this is the idea of the application. I'm going to show you anyway a video of a demo. So first of all, you select your criteria and assign weights. Then you simply click on the bottom to find your place, and then the map will appear. You can use the map controls to see the map in 2D and also 3D. And in the case of Milan, because Milan is so plain, you don't see a lot of 3D, but in other type of cities, you could see also the topography. You can check each criterion maps, not only the resulting map, but you can also check the different criteria. You can navigate to the location of interest or the vector layers, and then you can do it again. So this is mainly how it works. So I'm going to show you. If I can. Sorry about that. Yeah, but it's completely lost. Oh. I'll try it again. Okay. Oh, there it is. Okay. Okay, so these are the different criteria. The user just put the weights. And for each criteria, you have the caption that explains you how you assign the weights to each of the criteria in this way. Then you click and you get your map. You can zoom in and check the vector layers of the different services that you choose. Then you can check also the individual score maps. And then you can also see it in 3D, but of course, depending on the topography. And then you can do it again. So this is basically okay. So for future developments, we are thinking to the possibility for users to get a glimpse of the changing environment by giving like trends of the different criteria, like the temperature or other type of environmental criteria. We have the final map, but we don't put the name, for example, of the neighborhoods. So we want to put also that. Maybe take more advantage of the 3D functionalities, so elevate cells according to the cells values, for example. We don't have user administration functionalities yet, but the idea is to collect people's choices. So in the future, we can have a lot of data for research or maybe for urban management or marketing analytics. We want to add information about house rent prices, but this is, I mean, in the city of Milan, we're trying to make contact with some real estate companies to add this information. And as a first case study, we consider the city of Milan, but of course in the future we want to add more different cities. So you can check the application on this link, and you can find also the source code and documentation in GitHub. And you can download it, use it as you want. So thank you for your attention. So there is any question? Yeah.
Any support for custom filtering on the layers? For example, everyone knows that there are schools and there are schools. And if I only want to be close to the best part of it, how feasible is it to add the custom layer there?
It is feasible. Sorry, the question was if there is like filtering capabilities to the application. We don't have it yet, but for sure it's really feasible. Yes?
How do you get the data that you build the map from? Like supermarkets, they open, they close.
Yeah.
Do you do a complete re-import of your data every time, or you just do the data?
So the question is if we update our data for the application. And actually, not yet. I mean, this was a demo for the MyGeos call. But the idea, yeah, of course, is to update it. I mean, to have like a practically real-time update of the data, especially if they are from OpenStreetMap. But we don't have it yet, and we are thinking on that. Yes?
Yes, you mentioned at the beginning you moved to a city, you look at house prices.
Yeah.
Have you looked at whether your heat map of what's a good place to live according to you matches house prices? Like, can you see good places to live that are more expensive?
Yeah, so the question is if we checked the house prices within our application, and the answer is that, I mean, we want this data to be inside our application, but we don't have it yet because normally, especially in the city of Milan, all this data is private. It belongs to private companies, and so we don't have it yet, but we are trying to negotiate to put them on the application. We do it manually, like just to test, and yeah, you can do it more or less, but the idea is to include it in the application.
And so, like, just by your impression, it matches?
Yeah.
The pleasant places are expensive?
Yeah, in some cases, yes. The question is that if the the houses with the best prices match the options of the people, and normally yes. We were afraid in the future also the fact that maybe people will, because the idea is to create a map that then we will show like the best places that people prefer and stuff like that. We are afraid that this maybe change the market in the city, because you see maybe the map of the areas that people prefer. So we are not sure if we want that. We are trying to see how to portray this data. Yeah.
How good is the tooling around that? Because I'm thinking, if I can plug in Berlin there, how much time it will take me, how much effort it will take me? Should I sanitize the data myself, or I can just plug it into the OpenStreetMap source and other sources?
No, we did it very manually, in the sense that so the question is that if we can replicate this application to another city easily, and depends, because we actually take the OpenStreetMap data and we download the data. So we didn't use any API or anything, and we did it very manually. So I guess if you use the APIs, it will be easier. So, but we didn't do that. Okay, thank you.